This is Algebra 2. We are on lesson 4-1, our brand new unit, Expanding Binomials. Today's date is the 26th, 11/26, and before we jump into the lesson, we have a lot of housekeeping to do. First and foremost, I need to talk about our calendar. So here we are on the 26th. We have this whole week, that week, that's 15 days by the time you get to the 14th. Plus the 17th day, which you have right before finals. That is 16 days before finals, which are the 18th through the 20th. On these 3 days, you have finals. So right now, including today, you have 16 days to get your grade where you want it to be. If you have missing assignments, you have 16 days to get those done. If you have quizzes or tests that you need to retake, you have 16 days to get that done. If you just need to get your grade where you want it to be, you have 16 days to get it done. Very limited time, everyone. All right. So that's my calendar upkeeping. Other things I need to say, we need to make sure that our unit guides are all up to date. So if I come over here in Google Classroom, you should have already done this, hopefully. Where are we? Algebra 2. Set up Unit 4 guide. If you click on that, you should be able to set that up. Make sure that you bookmark it up at the top in your bookmarks. You don't need your old bookmark. Some of us have not been updating our old unit guides, and I'm going to individually come talk to you, Chris, and just make sure that you're updating your unit guide for all of Unit 4. You will notice, let me just go to Andreas. You'll notice on our unit guides now, we have this weird thing where, scroll down, we have this solid black line here after quiz 3. The reason for that is because we won't have enough time to get through all of Unit 4, which is a very long unit compared to our other units, before the final, which means everything from that black line down is not going to be on the final. Everything from the black line up is going to be on the final. In fact, we're going to take quiz 3, and then we're going to have like 2 days to review, assuming that everything keeps on pace and we don't skip a day. All right, so your Unit 4 guide is now updated. Other housekeeping thing I need to talk about is Classcraft. So from here on out, I'm starting this today. Every single time that you have a substitute, everything on Classcraft is multiplied by 2. That means you can level up twice as fast, or you can die twice as fast. I've given the substitute instructions on how to keep track of giving XP and taking away HP. Every single time that she sees you doing something good, you get 200 XP, and you can get multiple of those throughout the day, and anything that you do bad is minus 20 HP. You can die really quick. Be on your best behavior for the substitute, and that will be consistent for all substitutes for the rest of the year and for the rest of my career probably. Are there any, okay, the other housekeeping thing is Classcraft. So right now you guys are all in one giant group still. That's going to be changing the first day that I'm back, which is theoretically going to be tomorrow, assuming that Riley gets better. So by tomorrow I'm going to have new groups, new seating chart, but try to heal everyone up to full HP before we have class tomorrow. Wow, okay, lots of housekeeping things. Let's finally jump into the lesson, 4-1. And I'm, by the way, assuming that you've already done the warm-up about Thanksgiving. There were just a few questions to answer. I'm looking forward to seeing what everyone did over Thanksgiving. Let's talk about Pascal's triangle. So I want you guys to just raise your hand if you've ever seen Pascal's triangle. It'll be fun. You can like look up from your computer to see people raising their hand or maybe not raising their hand. Have you ever seen Pascal's triangle before? Raise your hand. I'm raising my hand because I've seen this so many times. It is one of the coolest patterns in mathematics. This pattern can be used to expand binomials like we'll use for today's lesson. It can be used to find weird probabilities. You can just use it for so many cool patterns. Anyway, how does it work? First, make a triangle where each row starts with a 1 and ends with a 1 and gets progressively larger and larger. This has 1 block, 2 blocks, 3 blocks, 4 blocks, etc., etc. I'm going to label this first row row 0. The next row is going to be row 1, row 2, row 3, row 4, etc., etc. So there's going to be 5, 6, 7, and row 8. You might be asking yourself, why did you start with row 0? That will make sense in a sec. If you already know how to fill in Pascal's triangle, go ahead of me. Go ahead and do that. And if you don't know how to do it, I'll teach you now. The empty blocks are found by looking at the blocks that are touching them directly above. This one and this one are touching the block, which means I just add those two. 1 plus 1 is 2. All right, easy enough. Well, how do I find this block right here? This block right here is being touched by 1 and 2. So 1 plus 2 is 3. This block right here is being touched by 2 and 1, so 2 plus 1 is 3. All right, coming down to the next block. This block is 1 plus 3, which is 4. This block is 3 plus 3, which is 6. This block is 3 plus 1, which is 4. What I want you to do right now is pause the video, fill in the rest of Pascal's triangle. Technically, Pascal's triangle is infinite. We're only doing the first 8 rows of Pascal's triangle because I will never ask you to do more than that. Neither will Khan Academy. I think, in fact, all the questions I've looked at Khan Academy don't even go past 6. 7 and 8 you will never see from what I've seen. So fill in Pascal's triangle, pause the video now. All right, you've unpaused the video and you can play this times 2 speed if you want. This is 5, this is 10, 10, 5, this is 6, 15, 20, 15, 6, and you should be noticing the pattern that there's like some symmetry to it if I cut it directly in half. So you only have to do the first half and then you can just copy it backwards. So this is going to be 7, 22, no, 21. I can do math. This is going to be 35. Come on now. 35, 35. It's going to be copying from 21 and then 7. And then finally 8. And then it's going to be 28. This is going to be 56. This is going to be 70. And then I just copy backwards. So 56, 28, 56, 28, and 8. All right, so now it kind of makes sense why I call this row 0, because row 8 goes 1, 8, row 7 goes 1, 7, row 6 goes 1, 6. It makes a lot of sense to call these rows the way that is listed here. And you might be asking yourself the question now, why the heck are we doing this? This is kind of, isn't this like for elementary schoolers? Yes and no. It's used in a lot of high-level math, and this is one of the high-level math things that it's used for. And to see why we're going to use it, let's go ahead and see if we can find the pattern. So as you're calculating stuff down here, I want you to be looking at Pascal's triangle to see if you can spot anything and find the pattern to completely do to the power of 5 and to the power of 6 all on your own. So you're looking for every possible pattern that you see. All right, anything to the power of 0. I don't even care if I put a million A's and a million B's. Anything to the power of 0 is always, yeah, you got it, 1. And anything to the power of 1 is itself. So A plus B to the power of 1 is just A plus B. All right, this one is review from last unit. Last unit, we had a shortcut for squaring things. Do you remember it? It's how I got Riley to sleep, honestly. It's you square the first, double the product, square the last. So square the first, A squared. Double the product. Well, for the product of A and B is AB. Double that is 2AB. So plus 2AB. And then finally square the last. And now Riley is asleep, and he actually is asleep. And I'm bouncing him right now, B squared. All right, and then I took the liberty of doing 3 and 4 for you. I'm so nice. What a great teacher you have. And there they are. So, do you see any patterns? I need you to pause the video, pause it for like 5 minutes if you need to. Pause it for a long time. See if you can find your own pattern. I really don't want you to just continue the video. Pause it, struggle with it, use your whiteboard, find the patterns, see if you can find A plus B to the power of 5 and A plus B to the power of 6 all on your own. Well, I guess just do it to the power of 5 first, and I'll show you if you have it correct. See if you can do it. Pause me now. All right, so you've been working on this problem for like 10 minutes because you're such a great student, and you've unpaused the video because you finally have discovered most of the rules, if not all of the rules. All right, well, the first rule is this power right here is always the same power right here. So that means I'm starting off with A to the power of 5. And I know that these coefficients are the numbers in front of each of the variables. This was 1, 3, 3, 1. Hey! That's the same numbers in Pascal's triangle on row 3. Look at that. To the power of 3, I go to row 3. It goes 1, 3, 3, 1. What a useful pattern. So the coefficients were 1, 3, 3, 1. Does it match with the fourth one? The fourth one is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. You probably saw that as well, and that means that we can find the coefficients for the fifth row. 1, 5, 10, 10, 5, 1. So 1 plus 10 something plus 10 something. Wait, I skipped one, didn't I? Oh, I'm so sorry. I forgot my 5. 1 plus 5 something plus 5 something. Oh my god, I cannot think today. I don't know what's going on. Plus 10 plus 5, and then plus 1. All right, 1, 5, 10, 10, 5, 1. Okay, that matches up with that row. Now I'm good. All right, so to do the next part, I notice that a to the power 4 decreases each time I go to the right. To the power 4, 3, 2, 1, and then it doesn't exist because it's actually a to the power of 0. So it actually decreases each time. So a to the power of 5, a to the power of 4, a to the power of 3, a to the power of 2, a to the power of 1, which is just a, and a to the power of 0 is nothing. There's no a's there. Okay, what's the other pattern I see? The other pattern I see is that on the far right I have b to the power of 4, which is b to the power of 4, and it also decreases to the right. It goes power 4, 3, 2, 1, 0. So come back here. This is b, come on now, b to the power of 4, b to the power of 3, b to the power of 2, b to the power of, what's going on here? Oh my gosh, okay, I see my mistake, my bad. I should start with this power, not this power above it. 8 to the power, so it's b to the power of 5, sorry about that. B to the power of 5, b to the power of 4, b to the power of 3, b to the power of 2, b to the power of 1, which is b, and b to the power of 0 is 1. That is the correct answer for expanding a plus b to the power of 5. Now that you know the trick, or maybe you already found the trick on your own, and now you verified it, expand a plus b to the power of 6 all on your own. Pause the video. I expect you to pause it for 1 or 2 minutes. Go ahead and do that now. Alright, so I did give us 2 lines because this is a long problem. So the coefficients for row 6 are 1, 6, 15, 20, 15, 6, 1. Let's go ahead and write those down. 1, and then 6. Come on now. Oh my god. Why do you do this, computer? 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 6 plus 1. Alright, those are all my coefficients. Maybe you were able to squeeze it all into the same line. If so, props to you. And then I know that my powers of a, I'll do that in orange, my powers of a start with 6. a to the power of 6, a to the power of 5, a to the power of 4, a to the power of 3, a to the power of 2, a to the power of 1, and a to the power of 0 is just 1. Next I have my b's. My b's start here. They start with the power of 6. 6, come on now, 6, 5, b to the power of 4, b to the power of 3, b to the power of 2, b to the power of 1, and b to the power of 0. There is my my expansion. Make sure that I have pluses in between each of these. Plus, plus. I know this looks really messy. I apologize. If I was not bouncing my son, I'm sure I could write a lot better. All right. So you know how to expand, and I know that they take a long time, but they do get harder to, and just be ready for it. So we have 3 examples, 1, 2, and 3. So go ahead and expand them. I want to do the first one and probably second one. I think I need to do each of these with you because each of them has a trick that we might not have ever seen before. Okay, so to the power of 4, that means I'm going in the 4th row. Oh, thank you. I don't have to go all the way down here to the 6th row. So 1, 4, 6, 4, 1. Let's go ahead and write down those coefficients. 1 plus 4 plus 6 plus 4 plus 1. Okay, I have my coefficients set up. I know that my first term is going to be this whole thing 3x to the power of 4. And I can't just leave that 3x to the power of 4. I need to actually figure out what 3 to the power of 4 is. And if you don't know, you have to go 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So on my first, for my x's, I have, this is going to be times 81x to the power of 4. That's an x right there. Come on. Okay, next. I have 3 less. So I divide 81 by 3, and I think that's 27. It's 9 times 3, which is, 27. So I'm going to multiply 4 times 27x to the power x to the power of 3. And then I'm going to go down even another step. That's going to be 9x to the power of 2. Then 3x to the power of 1, and then no x. Alright, and then I need to go backwards. with my y's to the power of 4. And this is easier because there's no coefficient, so you just go straight y to the power of 4, y to the power of 3, y to the power of 2, y, and no y. And of course you need to simplify, so my final answer down here, 1 times 81, that's pretty simple. That's 81x to the power of 4. 4 times 27, well 7 times 4 is 28, carry the 2, I know that ends with 8, carrying the 2, 4 times 2 is 8, carrying the 2 is 10, so it's 108, so plus 108 x cubed y, plus 6 times 9 is 54, so 54 x, that's a bad x squared y squared, plus 12x y cubed, plus y to the 4th, and there's my final answer. I can box this because I have technology. If I did this just with my normal handwriting, I'm sure that it would look super bad. Alright, there is my final answer. Haha, technology. Although that's like way too thick. Let's make it like, yeah, better. Alright, example number 2. I need to expand this guy. So go ahead and set it up the same way. You might actually be able to do this on your own. Just be careful with doing your denominators. And I'll give you your hint right off the bat before you pause the video, which is this. 1 over z to the power of 3 is equal to 1 over z to the power of 3. With that hint, go ahead and try this problem. Alright, you've unpaused the video because you have finished example 2, and I'm trusting you guys. Please do try it on your own. Here we go. Coefficients to the power of 5. Power of 5 means it's 1, 5, 10, 10, 5, 1. And I'd like to just do a brief tangent right now before I begin the answer here. My brief tangent is this. I could have taken this lesson with a whole different turn. I could have manually computed what a plus b to the power of 5 is and showed you why the shortcut is so much easier. If you're ever rolling your eyes because you hate doing all this math, I'm telling you right now, it could be like times 10 worse if you did this manually by hand. This Pascal's triangle is a huge time saver shortcut. So just know that in the back of your mind. And if you guys complain too much, I'm going to make sure that you always see the hard part first. So my coefficients for 5, 1, 5, 10, 10, so 1 plus 5 plus 10 plus 10 plus 5 plus 1. Hopefully that's enough room to write everything. Okay, so first term is z, so z to the power of 5, z to the power of 5, z to the power of, I can't write z's, z to the power of 4, z to the power of 3, z to the power of 2, and then z. Alright, next I have 1 over z, which is going to start with 1 over z to the power of 5. This is going to be 1 over z to the power of 4. This is going to be 1 over z to the power of 3, 1 over z to the power of 2. This is going to be 1 over z to the power of 1, which is just 1 over z, and nothing there. And notice that things are going to start canceling out here. Specifically, z to the power of 4, and then z on the bottom. This is z to the power of 1 again. So z to the power of 4 divided by z to the power of 1 is just z to the power of 3. I can subtract the exponent. That's your rules of exponents. So my final answer here is z to the power of 5 plus 5z to the power of 3 plus 10z to the power of 3 minus 2 is just z, so it's just the power of 1, and then plus 10, now it's going to be to the power of times z to the power of negative 1, or I could have left this 10 times 1 over z. You can keep it in either form. I like it this way so there's no fractions. And then plus 5 to the power of z to the power of negative 3. 1 minus 4 is negative 3. And then finally plus z to the power of negative 5. There's my final answer, and I have my rectangle tool so I can just box it. Alright, go ahead and flip your paper over to the back. We are now on our final example. This is the hardest type of question I will ever ask you. It's hard because there's a coefficient in the first term and the second term. It's a giant number. That's the biggest number I'll ever ask of you, and I have a negative sign. The negative sign is super difficult, well, not really difficult, but it's usually the most forgotten thing when you're expanding these. This whole term right here is a negative 2y. So remember, if I have a negative to an odd power, that's a negative. If I have a negative to an even power, that's going to be a positive. That's your trick for solving this. You know all the tricks now. This is all of a negative 2y. Go ahead and solve this on your own. Alright, you've unpaused the video, and this is a large problem, so here we go. I'm going to make sure that we really understand what's going on here. We are on the 6th row, so it's 6, 1, 6, 15, 20, 15, 6, 1. I have to write all those down. So, 1 plus 6 plus 15 plus 20 plus 15, yep, plus 6 plus 1. I'm giving myself lots of room because I know 3 to the power of 6 is a big, big number. Alright, let's go ahead and do our 3w's. So 3w to the power of 6. Well, I need to do 3 to the power of 6, so let's go ahead and work on the side here. 3 times 3 times 3 times 3 times 3 times 3. There are 6 of those. 3 times 3, 9. 3 times 3, 9. 3 times 3 is 9. 9 times 9 is 81. 81 times 9 here. Can I do this in my head? 9 times 1 is 9. 9 times 8 is 72. Going out, 72. So that means these two combined to form 729. I don't trust myself, so I'm going to use my calculator to check. 3 to the power of 6 is 729. Nice. Alright, so coming all the way back here, this is now going to be 729w to the power of 6. And I need to divide by 3, so what's 81 times 3 instead of 81 times 9? 81 times 3 is 243. So this is times 243 w to the 6. I'm not going to have enough room here, am I? Oh well. And 15, that's going to be times 81. 81 w to the power. Did you catch that mistake back here? If you caught it before I caught it, give yourself the extra credit point. Trust-based system. What I should have written here was the power of 5. Power of 5, power of 4. This is going to be 81 divided by 3 is 27. So this is going to be times 27 w to the power of 3. 27 divided by 3 is 9, so this is times 9 w to the power of 2 times 3w and no w. Alright, that was the first half. Here comes the second half, which is slightly challenging. We need to do negative 2y to the power of 6 to get to here. I know that since it's to the power of an even, it's going to be a positive number. Now I just need to find what 2 to the power of 6 is. So again, scratch work. 2, 2, oh, 2, 2, 2, 2, 2, that's 6 of them. 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. Oh, maybe I don't want to do it this way, but I know that 16 times 4 is 64. You could have done 16 times 2 again, which is actually what I did in my head because I forgot how to multiply 16 times 4 really fast. So 64. So this is going to be 64y to the power of 6, and it was positive. This next one is going to be negative. I'm going to go ahead and preemptively put a negative sign here because I know it's going to be a negative 2y to the power of 5. That's what's going here. And because it's an odd power to the power of 5, it's going to be a negative. That's where this negative came from. Alright, 2 to the power of 5 now is 32. So this is times 32y to the power of 5. This is going to be a positive, so we're good here because it's an even power. This is negative 2 to the power of 4, which is a 16. So 16y to the power of 4. Over here we have an 8y to the power of 3. Oh, it's an odd power. That means this is going to be a negative. And then this is going to be a 4y to the power of 2. It's an even power, so it's positive. And this is going to be a 2y to the power of 1. Ooh, power of 1, 1 is odd, so this is going to be a negative, and there's no y there. Alright, very messy work, I know that, and I'm going to go ahead and just blame Riley, because I can. I need to multiply all of these numbers out. So I need to multiply 6 times 243 times 2. And you won't have a calculator on the test nor the quiz, so get used to doing these without a calculator. I will also restrain myself and only use my head and my paper. So my final answer, and it's going to be 2 lines because it's so big, 729 w to the power of 6. Okay, I need to multiply all of these together. Well, I know that 2 times 243 is 486, so I need to, on my scratch paper, say, what is 486? I think I'm multiplying by 6 here, is that right? 486 times 6, yep. 6 times 6 is 36, carry the 3. 8 times 6 is 48, 48 plus 3 is 51, carry the 5. 6 times 4 is 24, plus 5 is 29, 2,916, oops. Minus 2,916 w to the 5th y. Alright, I need to multiply 15 times 81 times 4. Well, I know times 4 is the same thing as times 2 and times 2 again. So 15 times 2 is 30, times 2 again is 60. So I'm really doing 60 times 81, which is really 6 times 81 and add on a 0. So I'm in my head now doing 6 times 81. 6 times 81, 6 times 8 is 48. So let's say plus 48. Oh, add on the 0. So 480. This is going to be w to the power of 4, y to the power of 2. Next, I'm going to have a subtract, because it's a minus here. I need to multiply all of these guys together. Alright, well, 8 is the same thing as multiplying 2 times 2 times 2. So that's going to be, let's multiply 2 times 2 times 2 with the 27. It's going to be fun. 54 after the first time, so let me write down my notes here in green. So this is 54 after the first one, then 108, and then 216. So that's 216 is 27 times 8. And then 216 times 20, just double this again and add a 0. 432 with a 0 is 4320 w cubed y cubed. Alright, next we have 15 times 9 times 16. What's the easiest way to do this one? I don't know what the best shortcutty way to do this problem is. I'm going to do 16 times 15 first. So I'm multiplying by 2 4 times. So it's going to do, here's my scratch work. 15 goes to 30, then 60, then 120, then 240, which means 15 times 16 is 240. And that makes sense, right? 1, 2, 3, 4. I'm doubting myself. 15 times 16. Yeah, I got it. 240. And now 240 times 9 is the same thing as 24 times 9 to add the 0. So let's see if I can do 24 times 9 in my head. 4 times 9 is 36. So let's go ahead and write down 36. Carry the 3. So 3 is locked in my mind. 2 times 8, or 2 times 9 is 18. Carry the 3 is 21. 21, 6, copy the 0 down. I think I got that right. Go ahead and check my math if you don't believe me. W squared y to the 4th, and that's being added, not subtracted. And we have 2 more terms left, but they're getting easier and easier now. Alright, 3 times 32 is 96. 96 times 6. Ooh, 96 times 6. 96 times 6. It's the same thing. Well, that's 36, carry the 3. So that's 36, carry the 3. 6 times 9 is 54, plus that carried 3 is 57. So 57, 576. I have w, y, oop, lag there. W, y to the power of 5. And that's being subtracted. And then finally, plus 64 y to the power of 6. Yeah, that was a hard problem. I'll grant you that. That's like a level 10 out of 10 that you'll ever see. You will never see a harder problem than that. All right, that concludes the notes. Go ahead and write your summary and then begin the work on Khan Academy.